Hey, this is Mr. Ward, and this is the Algebra Do Now 29.3 video key. So here we go. So turns out x squared minus 25 could be expressed as x squared plus 0x minus 25. So what are two factors of negative 25 that add up to 0? I'm going to go ahead and make one of my x diagrams like this, and I'll put a little multiplication dot here and a plus here. Okay, because what I need is two factors that multiply to make a product of 25, but add up to 0. And if you're thinking, well, 5 and negative 5 would do the job, you are right. And it turns out we can, of course, use this little structure to say this. I'm going to set up our linear factors here, our two linear binomials. Binomials means there's two terms. Trinomials means there's three terms. At any rate, I've got x plus 5 times x minus 5, and I've used this to work this all out. In fact, I also know that I've got an x-intercept now at negative 5, and I could find an x-intercept at positive 5 as well. So this thing would graph like this. Go through the x-axis at 5 and negative 5. And there would be the y-axis, and actually would go right through the vertex of this thing, which would be at 0, negative 25. I don't know why this thing is being so annoying. There, I made that sort of work. Okay, so here we go. The answers are 5 and negative 5. And the next question asks us to expand or multiply out x plus 5 times x minus 5. And you might be thinking, but Mr. Ward, we know it equals x squared minus 25 because you just showed us this. Well, let's be sure. We're going to multiply x times x, so that'll be x squared. We're going to multiply x times negative 5, so that'll be negative 5x. Then we'll multiply 5 times x, so that'll be plus 5x. And then finally, we will multiply 5 times negative 5, which will be negative 25. And then we can put the like terms together. 5x and negative 5x are just going to be plus 0x. And who needs to write that down? That's just going to be a whole lot of nothing. So we just say x squared minus 25. So anytime you see x, a perfect square minus another perfect square, you've got what's called a difference of squares. And that difference of squares is going to take the square root of x squared, which will be x, and the square root of 25, which will be 5. And it's going to set up a product of x of the square root of the x squared plus the square root of the 25. And that's going to be times the square root of the x minus the square root of the 25. So you can just break those down and organize that into this difference of squares structure. Well, let's take a look at the next one. The next one is doing a similar kind of deal. I'll use green this time. Okay, so here we go. Once again, we're making our little x. That's a multiplication dot. That's a plus. And we need two factors of negative 144. And we want those factors to also add up to 0. So if you thought of negative 12 and positive 12, you got it. Okay, so I'm going to do this, put an x in front of it, and we actually can use this structure to factor, reverse of multiplying, factoring. It's actually a form of division, to factor x squared minus 144 into x minus 12 times x plus 12. And then we just multiply it out to speech. So we got, of course, our factors were negative 12 and 12. I'm getting ahead of myself. In this one, now we're going to multiply those same factors, and they should equal this. Well, let's prove it. So we got x minus 12 times x plus 12. So x times x will be x squared. X times 12 will be 12x. X times negative 12 will be minus 12x. And then negative 12 times 12 will be minus 144. And we've got 12x minus 12x will be 0x. We can just get rid of that 0x, and it's just x squared minus 144. We have a difference of squares. And since the square root of this is 12 and the square root of this is x, this is going to be x plus 12 times x minus 12, which is exactly that. These two things, this difference and this sum of the same things, are called conjugates of each other. I'll spell that out for you. You've probably seen this word in world language. The word is a conjugate. So if I have a plus b and a minus b, okay, these are conjugates of each other. So the same two things added and the same two things subtracted. And if you multiply conjugates, you get a difference of square structure. All right, let's take a look at the last one. X squared plus 24x plus 144. What are two factors of 144, this time it's positive, that add up to 24. So we want 24 as our sum, so plus, and we want 144 as our product. So a product means we are multiplying. So what are two factors of 144 that add up to 24? Well, 12 and 12 will do the job. And then once again, I can set up my parentheses, and I can just go ahead and factor this. X plus 12, okay, which means that an x-intercept will be negative 12, and x plus 12 again. So I'm going to be using, I've got the same x-intercept twice, so it's just negative 12. So this would end up graphing like this, okay? So since it's the same x-intercept, I'm going to have it at negative 12. And this thing will graph like this. I drew it. We'll say that's negative 12. Okay? And it's going to graph like that. Somewhere up here on the y-axis, it's going to go through at 144. I know that's not to scale. That'll be the y-intercept, because it's plus 144. So there's just things to know. So our answers are 12 and 12. And when we multiply out the exact same thing, which is x plus 12 squared, what we're going to get is a perfect square product. So it's going to be x squared. Let me actually get rid of that uppercase. X squared, because x times x, then plus 12x, and plus another 12x, and then plus 144. And I can take those two 12x's and I can write them as, bring this together, I can write that, I'm going to put a parenthesis around that. I can say two 12x's. And then I can further simplify it and say x squared plus 24x plus 144, which is what we had up here. This is a perfect square structure where you're going to have the square of the first term plus 2 times first term times the last term, which was 12 times x, and then you will have the square of the last term, 12 squared, which is, of course, 144. Perfect square structure. All right, I hope that helped.